In this series of videos, we're going to look at the odds of winning the UK National Lottery. Before we do this, let's first cover the basic rules. The lottery has a very simple structure. You pay £2 to select any 6 numbers from 1 to 59. You're hoping to match as many numbers as possible in any order against the 6 different balls randomly selected by the machine. Each number from 1 to 59 is equally likely to be chosen by the machine, and once drawn, the balls are not returned. If you match 3 numbers, you win a cash prize. The more numbers you match, the bigger the prize you win. Match all 6 and you win the jackpot. To understand the odds relating to the lottery, let's first do some probability recap. The probability of a desired outcome occurring out of some number of equally likely outcomes is given by this fraction here. For example, let's consider the probability of landing on an even number when we roll a fair 6-sided die. A fair die just means each of the 6 numbers is equally likely to be rolled. The outcomes we want are that it lands on 2, 4 or 6, so there are 3 of these, and there are 6 total possible outcomes, since the die may land on any one of the 6 numbers. By our equation, the probability of landing on an even number is therefore 3 in 6, which simplifies to a half. Let's start by looking at calculating the odds of winning the jackpot from a more mathsy approach. Imagine there are 3 children waiting for a face paint, but unfortunately there is only enough for 2 of them. How many different ways are there to pick the 2 children for the face paint? That is, how many different pairs can we form from the 3 children? The answer is of course just 3. The pair consisting of the first and second child, the pair consisting of the second and third child, or the pair consisting of the first and third child receive the face paint respectively. So this was easy enough, right? But what if we wanted to choose, say, 6 children from 59 for a face paint? How many different groups of 6 would there be for us to choose from in that case? If we use the same approach as before and just list every single possibility, then this might take us a while. But worry not, for algebra has a concise equation that works for any such problem. Indeed, the number of ways of choosing r things from a group of n different things, with the order of how we choose is unimportant, and we're not allowed to choose the same thing more than once, is given by this funny looking thing here. Don't be afraid of it though, it's just a fraction. And n and r stand for whole numbers. But why are you so excited writing the terms n, r and n minus r, I hear you ask? Well actually, in maths, these exclamation marks have a different meaning to the usual one. They're instead called factorials, and n factorial means multiply all whole numbers from n downwards until you get to 1. So if n is 5 for example, then n factorial is 5 factorial, and this is just 120. To convince ourselves that this formula does actually work, let's revisit our example of choosing 2 children from a group of 3 for a face paint. Notice how we are choosing 2 things, children, from a group of 3 different things, children, where it doesn't matter which child of the 2 who do receive a face paint is chosen first, and hopefully we're not planning on just choosing one child twice. So we can use the formula plugging in n as 3, r as 2, and n minus r therefore as 1, to get a fraction that simplifies to 6 over 2, which is of course just 3. And a similar but slightly longer calculation tells us that the number of different groups of 6 that may receive the face paint from the 59 children is just over 45 million, where we've replaced most of the numbers with dots to save space and because it's obvious which are missing. Feel free to pause the video at this stage to convince yourselves that this is indeed true. In fact, this exact same calculation is required for our lottery problem, because it tells us the number of ways of choosing 6 balls from 59, where order is unimportant and repetition is forbidden. For the lottery, choosing 1, 2, 3, 4, 5, 6 is the same as choosing 6, 5, 4, 3, 2, 1 for example, and we're not going to choose one ball more than once. In other words then, the number of different possible tickets is given by just over 45 million, and since any such ticket is as likely as any other, we can use our formula, which tells us that the probability of winning the jackpot is approximately 1 in 45 million, where we've chosen 1 for our numerator as there is only one desired outcome, the winning one.